Right, so let's talk about a bit about factors that affect reaction rates, and these are the five factors. So we're going to go over them one by one. Okay, so starting with the chemical nature of reacting substrates, yeah, substances. Reactions that appear similar may have different rates under the same conditions, depending on the identity of the reactants. For example, अगर metal में से आयरन और सोडियम को एयर के साथ एक्सपोज करें तो सोडियम इज गोइंग टू completely react with air overnight, but iron is going to be barely affected. And if you expose calcium and sodium to water, calcium is going to react very moderately, but sodium is going to react almost explosively. Right? Then you have surface area of reacting substances. Surface area बढ़ाने से reaction sites ज़्यादा हो जाती हैं, जिसकी वजह से total number of collisions ज़्यादा हो जाता है. And because there's a higher number of frequency of collisions, there's going to be a higher reaction rate. Then we have temperature of reaction, और जैसे जैसे हम temperature बढ़ाते जाएंगे वैसे वैसे ही आपका जो reaction का rate है it's going to speed up. For example, food can spoil quickly when it is left on the kitchen counter, लेकिन अगर हम fridge में उसे रख दें और temperature उसका कम कर दें तो it can remain fresh for days. And इसी तरह से we use a burner or a hot plate in the laboratory to increase the speed of reactions that proceed at very slow rates at ordinary temperatures. And here you have a graphical visualization of how the reaction rate is going to increase if you increase the temperature. So extending on that, basically जब temperature increase करता है तो number of collisions are going to increase among the reactant molecules. Right, so an increase of 10 degrees Celsius in temperature will approximately double the rate of reaction in a homogeneous system. Right. Moving on to the concentration of reactants, ठीक है? So the rate will usually increase when the concentration of one or more reactants is going to increase. For example, calcium carbonate is going to deteriorate as a result of its reaction with sulfur dioxide. और ये रिएक्शन डिपेंड करता है कि आपके एटमॉस्फेयर में कितना सल्फर डाइऑक्साइड है. सो द एसिडिक ऑक्साइड जो कि सल्फर डाइऑक्साइड है इज गोइंग टू कंबाइन विद वाटर वेपर और सल्फ्यूरस एसिड सॉरी वो प्रोड्यूस करेगी, एंड दिस इज द रिएक्शन वेयर बाय इट्स गोइंग टू रिएक्ट विद calcium carbonate to produce calcium sulfate and CO2 and H2O. Right? So, in a polluted atmosphere where the concentration of sulfur dioxide is high, calcium carbonate deteriorates more rapidly than in less polluted air. Similarly, phosphorus burns much more rapidly in an atmosphere of pure oxygen compared to an atmosphere जहाँ पे सिर्फ 20% oxygen है. And finally, we have the presence of a catalyst. And catalyst को एक activation energy require. Basically, any reaction needs an activation energy, which is the minimum amount of energy required for a chemical reaction to proceed in the forward direction. तो कैटलिस्ट क्या करता है, वो इस एक्टिवेशन एनर्जी को रिलीज लोअर कर देता है. ठीक है, अब किस किस तरह से लोअर करता है? इट इंक्रीजेस द फ्रीक्वेंसी ऑफ कोलिजन्स बिटवीन द रिएक्टेंट मॉलिक्यूल्स, changes the relative orientation of the reactant molecules, or donates more electron density to the reactant molecules. It could also reduce the intramolecular bonding within the reactant molecules, or provide an alternative pathway or mechanism for the reaction. Right? So I'm sure by now all of you have seen this graph. ठीक है ना? यहाँ पे reactants हैं, यहाँ पे products हैं, and this is the activation energy that is initially needed, but the second black line indicates how it has been lowered.